Okay, so we're going to take some notes, redo this rational exponents lesson. So we're going to make this booklet, so I'm just going to quickly go through it. You can stop the tape and watch it again. This is, you want to fold your two worksheets so that the first one has a 1 in the bottom and it's facing upward like a booklet. I've drawn a line down here and I'm going to cut that out. So take scissors, cut it out. So what I do, watch, cutting, just cutting on that line so that I'm creating a hole in this worksheet. Okay, now that's the first one. The second one, you fold it so that it's a booklet with the 3 in the front. Now, notice where I've drawn. I've drawn lines at the top and the bottom, and I'm just going to cut on those lines. Okay, now what I'm going to do is I'm going to take the front of my booklet, that's page 1. I'm going to, you see that it's 1, and then you open it, it's 2. I want 3 next. So I take this page that is 3, I'm going to roll it up, because that helps me to insert it. So I'm rolling 3. I'm going to open this booklet, push it in here, and pull it through only halfway. Now I'm going to unroll it so that it looks like this, where I have the first page of the booklet and the last page of the booklet. And then I fold this over, and now I have a booklet of notes. So here we go. Rational exponent. If the nth root, there's n, the denominator of your exponent fraction, of b is a real number, and m is an integer, meaning the numerator of your rational exponent, then b to the 1 over n is equal to the nth root of b, and b to the m over n is equal to the nth root of b to the m. Okay, so these are examples. The square root of 49 is 49 to the 1/2. X to the 3/5 is x to the 3rd, the 5th root of that. All right, so let's review the properties. If I have, I'm going to zoom in a little bit. Okay. If I have the same base to different exponents and I want to multiply them together, it's b to the m plus n. So if I have x to the 4th times x to the 7th, that is equal to x to the 11th. Now, if I take a base that's already raised to a power, raise it to another power, that's where I multiply. So if I have x to the 1/2 and I raise it to the 3rd, I'm going to take those exponents and multiply them, and that becomes x to the 3/2. If I have two different bases taken to the same power, that is equal to a to that power and b to that power. So if I have 3x squared, that is equal to 3 squared, 9, times x squared. Now, negative exponents. If I have b to a negative m, then I have 1 over b to the positive m. If I have x to the negative 3rd, that is equal to 1 over x to the positive 3rd. Dividing exponents. What you do is you take the base and you raise that to the subtraction of m minus n. So if I have x to the 3/4 divided by x to the 1/2, what I do is that's going to be x. Now let's do these fraction subtraction. What is 3/4 minus 1/2? Get common denominators. 2 times 2 is 4. 1 times 2 is 2. I've got common denominators. I'm just subtracting. 3 minus 2 equals 1/4. So my answer to this quotient is x to the 1/4. Okay? That's how we do division. And if I have multiple variables, I just draw lines and I do all of the x's and then all of the y's and then all of the z's. Okay, if I have a fraction raised to 1 power, I raise the numerator to that power and the denominator to that power. If I have x over 3 squared, that is equal to the numerator squared over the denominator squared, which is 9. All right, so those are the review of the properties. Now we're going to use them. So here we want to find the simplified form. You can see that. Okay, we want to find the simplified form. One thing I want to point out is that when you have, we can rewrite this, remember, because all fraction exponents are really roots, so that's 3 to the 1/2 times 12 to the 1/2. Because they are to the same power, I can multiply them. I can put them under the same power, keep the power the same, and multiply 3 times 12, which is 36. Well, this will allow me to simplify because the square root of 36 is 6. Okay, so there's actually, each problem is individual. 63 to the 1/3. Okay, I can rewrite it if I wish as this is the same. 64 to the 1/3. And it's asking me what number multiplied by itself 3 times is equal to 64. So I say to myself, 4 times 4 is 16. 16 times 4 gives me 64. Therefore, the answer to this is 4. All right. This is like for problems you can't have a calculator. Looking at this problem, let's rewrite this. I have the 4th root of 4, the 4 to the 1/4, times the same root, same power, same n, 64. So I can combine those, and I can say 64 times 4. 64 times 4 is 256. So I can combine that to be the 4th root of 256. So if I take that and say what number multiplied by itself 4 times is 256, let me do that. I get 4. Okay? Equals 4. Okay? Because if I take 64 and multiply it by 4 one more time, I'm going to get 256. All right, let's do D, simplifying this. It's a negative 32 raised to the 3/5. Well, that could be written as negative 32 to the numerator, 3rd power, raise that to the 3rd power. It's an odd power, it's going to be negative, and take the 5th root of that. Okay, so what I could also write that as is I could take the negative 32, I'm seeing a way to simplify it. If I take negative 32 and I take it to the 5th root, and then I take whatever that is and take it to the 3rd power, that's going to be the same thing as 32 to the 3/5. And I know this. I know the 5th root of 32 is negative 2. So that would equal negative 2 raised to the 3rd power, which is equal to negative 8. Now, I think with a problem like this on your test, you can use a calculator, and you should get negative 8, remembering that a negative to an odd power is negative. Write the following in radical form. Radical form. So it's in fraction, rational form, and you want it in radical form. So I look at this, and I have a decimal. Well, I wonder what that is as a fraction. And if I want to use my calculator to help me with this, I can say 0.2. What is that as a fraction? Hit the math button, hit the frac button, 1/5. All right, so that is equal to W to the 1/5. Now that helps me write it in radical form, because that is just equal to, a rational is a radical. Take the 5, put it out here because it's in the denominator, W to the 1st power. And that's your answer. All right, now let's write this one? Well, I know that if I have a negative power, that's going to be 1 over w to the positive 5/8. But I'm not done because I'm not. That's going to be 1 over the 8th root of w to the 5th, and that's in radical form. All right, let's go the other way. Rewriting in exponential form. And you mostly do this because it's so much easier to work with fractions than with radicals. So this is going to be x to the 3/4 and y to the 4/5. My recommendation is that for every problem, change it to a rational and then work the problem. All right, let's keep moving. Okay, let's leave the rational exponents word problem till last. Let's keep going with our basics. All right, so here, this looks like I might look at that and say, I'm not sure what to do with that. But watch, if I rewrite it as 3 to the 1/2 times 3 to the 1/4, then just because of rewriting it, I know what to do. I just have to add the fractions. So I go over to the side or down here and I say 1/2 plus 1/4. Get my common denominator. 2 times 2 is 4. 1 times 2 is 2. I got my common denominator so that I could add my numerators. All right. So now my answer is the base to this exponent, 3/4. Okay. This one works the same way. Let's change it to its rational form. X to the 3/2. Remember, if it has nothing, it's a 2. Divided by x to the 2/3. So I come over here and I say, let's just do the subtraction of exponents. It's division. So for x, you take the numerator exponent, 3/2 minus 2/3. Simple fraction. So I'm going to change the denominator because I'm adding or subtracting fractions. 3 times 2 is 2. That's 4. That's 9 because I multiplied by 3 over 3. I have my common denominator, and now I subtract. 9 minus 4 is 5. So my answer is x to the 5/6. X to the 5/6. All right. Again, 7 to the 1/2 times 7 to the 1/3. Okay, add your exponents. We take 1/2 plus 1/3. We get our common denominators, and we get 5/6. So the answer is 7 to the 5/6. Okay, next page. Write each number in its simplest form. Well, let's look at 32 to the negative 4/5. Well, I know that is equal to 1 over 32 to the 4/5. And I know that 32, the 5th root of 32 is 2. So I'm going to write that over one more time. 1 over the 5th root of 32, I'm going to have to take that whole thing to the 4th power. And I can simplify this way because I know that that is 2. So that equals 1 over 2 to the 4th, which equals 1 over 16. Okay. Now, I also know that the 4th root of 16 is 2. So let's do this one again. If I write the 16 to the 4th, take the whole thing to the 3rd, and that's what this is, right? I just broke it down. If I were to redo it, it would be 16 to the 3/4. So the 4th root of 16 is 2, so 2 to the 3rd power equals 8. I'm just going back and forth, breaking them down. This one equals 3.5. Well, let's take our calculator out and get that fraction, okay? So I want to know what that is. 3.5 math fraction 7/2. Okay, so I have 9 to the negative 7/2. Okay, well, let's first get rid of that negative. 1 over 9 to the 7/2. Okay, now I know that the square root of 9 is 3, so let's break it down again. 1 over the square root of 9 raised to the 7th is equal to 1 over 3 to the 7th. 3 to the 7th, I would do in my calculator, is 1 over 2187. We don't expect you to know that. Okay, moving along. So now I'm working some problems. I take each piece. It might even be helpful to just draw a line to say, okay, what am I working with? How many operations do I have to do? First, I have to take 8 to the negative 1/3. So I'm going to do this on my calculator. 8 to the parentheses, negative 1/3. Negative 1/3. And I get 0.5, which is a half. Okay? So I get 0.5, you'll write it as a decimal, and then I take x to the 15 times, you multiply these exponents because I'm raising a power to a power. So that becomes x to the negative 15 thirds is negative 5. So I could rewrite that. That's fine the way it is, but I could also rewrite it as 1/2 times 1 over x to the 5th. Which I could rewrite as 1 over 2x to the 5th. But either one of these is fine. Okay, let's do this one. Now realize, I'm going to draw lines. I want you to see that this is really 3 different calculations. 9, x, and y. I take them each to the 3/2. So 9 to the 3/2 is 27. Do them all separately. 27. X to the 3/2 is just x to the 3/2 because you multiply 1 times 3/2. Now y, let's rewrite that. I have y to the 1/4 taken to the 3/2. So I'm going to multiply 1/4 times 3/2, which is 3/8. Y to the 3/8. And that's your final answer. All right, last one on this page. We're raising to a power. We're going to raise the numerator and the denominator separately. It's the same strategy. You're just multiplying the exponents. That equals x, all right, it's negative to the negative. I just multiply straight across because it's multiplication of fractions. Negative 30 over 3. I'm going to simplify that. Y, now I'm going to take negative 1/3 times 15 over 1, and I'm going to get negative 15 thirds. And I just multiplied negative 1/3 times 15. And that's how I got that. Now let's simplify. We have x to the negative 10 over y to the negative 5. Now what can I do with negatives? Because they're both negative, I could write this x to the negative 10. I could put it in the denominator and make it x to the positive 10. I could take this to the numerator and make it y to the positive 5. See how that works? And that is my best answer. All right, that's it. Last page. We're done. Let's go back. Kepler's third law of orbit shows you can approximate P, where D is the distance from the planet to the sun in AUs. All right, so anything with AU is distance. That's D. So if Mars is 1.5 AU from the sun, how many Earth years? Always figure out what they're asking. So they're asking for the period. They're asking for P. P equals, if they gave me D, 1.52 to the 3/2. So I would just plug that in and do the calculation. 1.52, raise it to the 3/2. And that would be 1.8, we'll just 1.87. 1.87, the period. That's how many Earth years. Okay. So almost 2 years. Find the length in Earth years. I'm still finding years of Venusian year. If Venus is this distance, 0.72 AU from the sun. So if I'm given a distance, so P is equal to 0.72 to the 3 halves. And I just calculate that. I do that on my calculator, and it's no mystery, 0.61 years. And this is the same. I'll let you do that on your own. Okay, go ahead and start. I want you to work through. I'm going to do one from each unit, and then I want you to complete this homework. Is this true or false? Have they done this correctly? Well, we look at this and we look at this, and first of all, they don't have the same base, so you're not going to just add the exponents. But this is what they did. You've got the third root of 27 times the third root of 8. So yes, they can multiply and keep it to the same root. True. Okay? So you're basically checking their work. Did they do it correctly? Yes, they did. So if I were you, I'd take the problem, work it like you would work it to see if they did the right thing. Okay? Now let's look at this one. Identify the exponent. So this is 7 to the question mark. We don't know what that is. So let's rewrite it. 7 to the 1/2, that whole thing raised to the 1/2. Well, I know what to do as soon as I write it like that. It's 7 to the 1/4. So 1/4 is the answer. All right, let's do one of the last ones. Write each in radical form. You totally know how to do that. If I have that, that is equal to the third root of x squared. Go ahead and do the rest. You know how to write an exponential form. That is y to the 3 goes in the numerator, 2 is in the denominator. Simplify the expression. So this means I might know the third root of 64, and then I can square it. And you can use your calculator for this. But I want you to see, obviously you could do that whole thing on your calculator, but let's try to break it down. The third root of 64, then you'll know that. And if you think about it, 4 times 4 times 4, that's 4 squared is 16. So breaking it apart can be even faster than the calculator. All right, so this is really the 5th root of 32, which is just 2. All right, I'll let you do the rest. And these are regular problems that we've been doing. If you have a division problem, you might want to write it m to the 5/7 over m to the 3/14, and that may just say to you, oh, that makes me remember what to do. It's division, so I subtract. Okay. Next page, anything different? Now we're multiplying. With 31, we just multiply the coefficients as we normally would. But here, we've got the same base, different exponents, so we just do a little scratch work. The exponent of x is 2/5 plus 1/4. I have to get common denominators and add. So that is equal to 13/20. So the answer is x to the 13/20. Okay. All right. And I'll just let you do your best with 37 and 38. Okay, good luck, and bring this back in for redo your test or for extra credit.